Alright, so this is question 2 from exercise 6C, and they're a little bit tricky at first, so it's quite alright to be asking these. It's good, in fact, to be asking your questions in the collaboration space, so that I've got a chance to help you out. Let's see how we do this one. Here we've got an equation, it's a quadratic, and it's got all these annoying k's in it, so we don't know the exact value of any of the coefficients, but that's okay. Is such that, so this equation is such that the sum of its roots is twice their product. So what is the sum of the roots? Alpha plus beta, and if we remember correctly, it's negative b over a, and the product of its roots is c over a. And now we're told the sum of its roots is twice the product of the roots. So negative b over a equals 2 times c over a. Sum of the roots double product of the roots. Okay, well you can see here the a's, if I just multiply through by a, that's going to cancel. So I've got negative b is going to equal 2c. If I have this negative b, and b is already negative, that's going to leave me with just the positive 1 plus k. So 1 plus k is going to be equal to 2 times c, which is 3k plus 2. And a little bit of expanding here. Let's get our little equivalent signs happening, why not? 6k plus 4 on that side. I'm going to subtract k, which will give me 5k on the right, and the k's disappeared. And I'm going to subtract 4 from each side, which is going to give me negative 3 equals 5k, or negative 3 over 5 equals k. So we've done the first bit, we have found k, so we can tick that off and find the two roots. So I've got to find alpha and I've got to find beta. Well, here we're really set up for two simultaneous equations, aren't we? We've got alpha plus beta, so the sum of the two roots is going to equal negative b over a, and I've got alpha times beta equals c over a. That's one way you could do it. The other way you could do it, you could simply substitute in k in each of the different points, so there, and there. And then of course from there, what do? Well, then we can just solve the equation. That will give me the two roots. Let's try both ways and see which way you prefer. So let's first of all go with the alpha plus beta equals negative b over a. So 1 plus k divided by, so that's negative b, and b was already negative, so the negatives cancel. So I've just got 1 plus k over k. That's equal to alpha plus beta. And what's another way? Oh, that's good enough. And then the other one, c divided by a. So 3k plus 2 divided by k is equal to alpha times beta. Now these are usually annoying where you've got an addition and then a multiplication. They're not nice ones. You can't just use elimination. So we have to go with another way of doing this. Substitution looks like it's going to be the easiest. Let's see how we go with that. I might just rearrange this first one to say that's equivalent to saying alpha is equal to 1 plus k divided by k minus beta. I can now substitute that in to the second equation there. So I'm going to have 3k plus 2 over k equals 1 plus k over k minus beta times beta. Now, this is looking pretty messy, isn't it? But we've forgot to use the important bit of information that we've been given. You could have done this at the start. I could have done this first, and maybe that may have made it a bit easier for you. But we didn't sub in the negative 3/5 for k, and I can do that at any point, and this would simplify nicely. I think looking at how ugly that is, that's going to really annoy you if I try to expand that. So I might just go back and let's make that substitution first. So before I even rearrange that, I've got 1 plus k divided by k equals alpha plus beta. So that's equivalent to, if k is equal to negative 3/5, I've got 1 minus 3/5 is 2/5 divided by negative 3/5, and that's equal to alpha plus beta. Now, when I sort that out, that's just negative 2/3 equals alpha plus beta. That's pretty messy, isn't it? You can see I'm trying to squish it in to get it inside the region there. And I'm a little bit out of practice. I haven't used this one where I can't write on the screen. I've got to write on my little tablet where it doesn't show up. So that's looking a little bit better. How can I make that? So therefore, let's get that substitution happening. So beta would be equal to negative 2/3 minus alpha. That would be a substitution I'll be able to make now. So all I did was negative 2/3 subtract alpha, and that's what beta is equal to. Over here, I'm going to sub in the same value, negative 3/5 for k, so it's going to be negative 9/5 plus 2 divided by negative 3/5 equals alpha times beta. When I simplify that, I've got 1/5 over negative 3/5, which is just negative 1/3 equals alpha beta. That makes sense, doesn't it? The sum of its roots is twice its product. Well, we've definitely confirmed that that's true. Negative 2/3 is indeed double negative 1/3. So now what can I do? Let's make that substitution. Just going to go over here so we've got enough room. Sub negative 2/3 minus alpha for beta in, let's call that equation 2. This was equation 1 that I'm going to substitute in. Therefore, negative 1/3 is equal to negative 2/3 minus alpha multiplied by alpha. I should have substituted in for beta. Let's put it on the other side. Doesn't matter. That's okay. This is going to be easy to solve now, isn't it? So what sort of equation have I got? I've got a quadratic. I really don't like this negative 1/3. Let's expand the right-hand side. Then we'll sort it all out. Negative 1/3 equals negative 2/3 alpha minus alpha squared. Set the whole lot equal to 0. So I'm going to add alpha squared to each side. So I've got alpha squared. I'm going to add 2/3 alpha minus 1/3 equals 0. Straight away you can go ahead and use quadratic formula or factorize however you like here. These 3's annoy me, so let's just multiply through by 3. So I've got 3 alpha squared plus 2 alpha minus 1 equals 0. That's going to be a little bit easier to factorize. The coefficient in one bracket must be 3 alpha and the other one just alpha. And then I've got to have negative 1, so I'm going to have a positive 1 and a negative 1. I've got to end up with positive 2. So I must have positive 1 over here, negative 1 over there. Check it. 3 alpha by alpha is 3 alpha squared. 3 alpha by 1 is 3 alpha. Minus 1 alpha is 2 alpha. Oh yeah, negative 1 by that. That works nicely. Need to scroll down a little bit here. So therefore, null factor law, 3 alpha minus 1 equals 0, or alpha plus 1 equals 0. That's going to give me 3 alpha equals 1, alpha equals 1/3, or alpha equals negative 1. Recalling that beta equals negative 2/3 minus alpha, if alpha equals 1/3, beta is going to equal negative 2/3 minus alpha, which is 1/3, which is of course negative 1. And not surprisingly, that equals the other value of alpha because it's arbitrary which one I call alpha and beta. And when I do this, here, if alpha equals negative 1, beta is going to be negative 2/3 minus negative 1, which is of course equal to 1/3. So therefore, what were the things we ended up with? K equaled negative 5 over 3, and the two roots are negative 1 and, oh, that's an ugly ampersand, isn't it? Let's fix that up. Negative 1 and 1/3. So that's the first way we could do it. Remember I said we could go ahead and use the alpha and beta to those two equations, substitute in the value for k, do all that working, which is quite a lot of working, and eventually we would get to the solutions down here. We had k as, I wrote -5/3, it's -3/5. That's the only danger with not being able to see what you were doing. K is -3/5. And the two roots are -1. Oh, that was bad. That's much nicer. The two roots are -1. And 3, I promised you another way of doing it. Let's go back to this original equation now. To save me getting it wrong when I scroll down and can't see what I'm doing, I'm going to cut and paste that again. Bear with me while I create a little bit of room here. And remember we have k equals -3/5. So I would have -3/5 x squared minus 1 plus -3/5 x plus 3 times -3/5 plus 2 equals 0. -3/5 x squared. 1 minus 3/5 is 2/5, so it's going to be -2/5 x, and here -9/5 plus 2, -1/5 equals 0. Multiply through by negative, we'd multiply through by -5, that'll do. So then I'm going to have 3x squared, remembering that multiplying by -5, the negative would cancel and the 5 would cancel, so I just have 3x squared. Negative and negative would cancel, so this will be plus 2x when the 5's cancel. And here, multiplying by a negative and a negative gives me a positive, and that's just going to be a 1. Now, why did I have that? That should be a plus 1/5 because it was -9/5 plus 2 is positive 1/5. So when I multiply through by -5, it becomes negative. You can see that that's going to work then, and that's equal to 0. What do we do now? Factorize. It's the same one we had before, isn't it? This is 3x minus 1, x plus 1 equals 0, and the rest of the equation works out the same. Maybe that's a fair bit easier, I think, than persevering with this sum and product and simultaneous equations. As I said, simultaneous equations where you've got a sum and a product are pretty nasty and yucky. We can go ahead and, once we've found our value of k, substitute them in and get the answer much more easily. I hope that helps. I'm going to upload the video, and it's 13 minutes of your life you'll never get back. So don't forget it, because you don't want to have to sacrifice another 13 minutes doing it again. Have fun. See you in the next video, guys. Cheers.